Day 318 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 51 in Queens. The difficulty level is hard, but don't even worry because you already know we're going to keep that solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Question says, the n-queens puzzle is the problem of placing n-queens on an n-by-n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n-queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of n-queens placement where q and the period both indicate a queen and an empty space respectively. So, all right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples so we can make sure that we are doing this problem correctly. In example 1, we have n equals 4. So n equals 4, that lets us know that we're working with a 4 by 4 chessboard, and we want to place queens where no two queens can take each other or attack each other. So if you've never played chess, a queen can move vertically, it can move horizontally, and it can move diagonally. So that means we have to place our queens so that there are no other queens in a column, in a row, or in a diagonal to the right or a diagonal to the left in either direction, up or down, diagonally. So with that in mind, let's go ahead and take a look at the output. So in the output is a 2D array. Each array inside of the array equals a different row. So, it's not a 2D array. Or it is, well, this is it's a 2D array, but each array is the whole board, where each string in the array is a different row. So this right here is row 1 with the periods equaling a blank space, and the Q is the queen. So in this example, or this picture to the left, we have a space, queen, empty space, empty space. That's the first row. Then we come over to the second row. We have a empty space, empty space, empty space, queen. Then we come over to the third row. We have a queen, empty space, empty space, empty space. And then the last row, we have a empty space, queen, empty space. So, okay, yeah. So it is a 2D array, right? So this is the first array right here. Boom. And this first array is the whole board. And then each string inside this array represents a different column in that board. So this right here would be the second board. It's the same principle that we just went over in the first board, with the first row being blank space, queen, blank space, like it is, right here, because each string is a different row. Remember that. Then the second string is queen, empty space, empty space, empty space, and so on and so on. So we have to return, you may return the answer in any order. So in this case, we have two different ways that we can do it with, or that we can achieve completing the puzzle where no queens take each other. And so we return both of those solutions, this being the first board and this being the second board right here. The explanation says there exist two distinct solutions to the 4 queens puzzle as shown above. These are the two distinct solutions right here. Boom. So now in example 2, we have n equals 1, and since there's only one square, we can only place one queen, but it's still in the 2D array, right? So this equals the board, and this right here just equals the one row. And yeah, so the output is the 2D array. And yeah, that's example 2. So that's how the question works. I hope that makes sense to y'all, but just remember the rules of chess. Queen can move up and down as far as it wants. It can move left to right as far as it wants, and it can move diagonally as far as it wants as well, and we want to make it so that no two queens can attack each other. For example, if a queen was right here in this square, that means they can attack each other right here because they can move as much as they want. If a queen was right here, that means these two queens can attack each other because they're going diagonally. And if we move a queen right here, these two queens will be able to attack each other, and these two queens will be attacking each other. And we want to make it so no two queens can attack each other. So now that we understand the question, let's get into the fun part, the actual solution. We're going to be using some backtracking to solve this problem. So I hope you're excited about that if you're into backtracking problems. So let's get started. Now, the first thing we need to do is we need to create our 2D array, which is going to store all the valid board configurations where each board is represented as an array of columns and indices, or column indices. So in order to do that, to start, we just need to declare the variable, we call it res, and set that equal to a 2D array of integers. So that's square bracket, put the n inside, come outside the square bracket, and put the parentheses. So this 2D array, this 2D array is going to be this 2D array in output that we are going to create when we're building our code. Now, let's start with our backtracking function. We're going to use some recursion, so we're going to create this function inside of this main function, and we can just say func backtrack, open up the parentheses. It's going to pass in the parameter, just call it p. Then we'll say underscore p colon, then we'll open up, it's going to be an array of integers, so we'll say square bracket, put the int inside, come outside of that square bracket, but still inside the parentheses, and we'll just initialize it with a blank array like that by saying equal and put a blank square brackets like that. Then we're going to come outside of those parentheses, we're going to open up our brackets and get started on our function. So we'll say if p dot count equal sign n, we'll open up the brackets, and we'll say res dot append, open up the parentheses, p. So if we have placed n queens, we're going to add the valid configuration to the result. Boom. Then we're going to come underneath that if statement, and we need to copy the current queen placement. So in order to do that, we could come right here, we could just declare a variable, we call it pth, and we'll set that equal to p. Then we need a set of available columns for placing the next queen. So we could do declare another variable, we could just call it avb for the available columns, and we'll set that equal to, it's going to be a set, put less than, put an int inside, then put a greater sign, so it's going to be a set of integers, put the parentheses, or open up the parentheses, and inside those parentheses we're going to put 0 dot less than up to n, boom, n, then close the parentheses like that. So it's going to be 0 up to n, boom, equal white space on each side of that. Then we could get started in our for loop. So we'll say for I n, or excuse me, no, we're going to open up the parentheses. We're going to say for I comma, for I comma n pth dot enumerated. So what this enumerated does is it's going to get us the index and the value, boom, and the element, the number, whatever the element is. Then we're going to open up the brackets, and we need to remove all the invalid positions based on previous queen placements. So if we place a queen somewhere, we need to remove all the invalid positions, meaning if we put a queen somewhere and it's in a position that can attack another queen, then we need to remove one of those queens. So in order to do that, we'll just say if let idx equals avb dot first index, open up the parentheses of, then we'll say colon, we'll say n minus pth dot count plus I, come outside of those parentheses, we're going to open up some brackets, and we're going to, inside those brackets, we'll say avb dot remove, open up the parentheses, we'll say at colon IDX. Excuse me, IDX. And what that's going to do, that's going to remove the left diagonal conflicts. Then we're going to come underneath that and we'll say if let IDX equals AVB dot first index, open up the parentheses of colon n, this time just n, then we'll come outside of those parentheses, open up the brackets, we're going to say AVB dot remove, open up the parentheses at colon IDX. And this is going to remove same column conflict. So if it's in the same column, then we'll remove one of the queens. Now we need to do for the right diagonal, because we did the, this one is the left diagonal. Excuse me, this is the left diagonal. This is the column. And now we need to, this is the same column conflict, and now we need to move or remove the right diagonal conflict. So in order to do that, we come underneath this, we'll say if let IDX equals AVB dot first index, open up the parentheses of colon, then we'll say n plus PTH dot count minus I, excuse me, minus I, then we're going to open up the parentheses, open up the brackets, and we're going to say AVB dot remove, open up the parentheses at colon IDX, right, just like that. And once again, that's going to remove the right diagonal conflicts. Boom. Now we need to try placing a queen in available columns. So in order to do that, we're going to use a for loop, another for loop. So, well, first, so first we need to come outside of this for loop, and we'll start another for loop, and we're going to say for I in 0 and, 0 dot less than, so 0 up to n, where AVB dot contains, open up the parentheses, I, gonna come outside of those parentheses, we're gonna open up the bracket, we're gonna place the queen in column I, so we're gonna say PTH dot append, open up the parentheses I. Then we're gonna use some recursion to place the next queen. So we're gonna come right here, we're just gonna call the backtrack function, open up the parentheses, and we're going to pass in PTH. Then we're going to come right here, and we need to backtrack by removing the last place queen. So we're going to say PTH dot remove, open up the parentheses, at colon PTH dot count minus 1. Then we need to start the backtracking process. So we're going to come right here. Excuse me, I'll come right here, and we're just going to say backtrack and just put some parentheses. Then we come right here, and we're going to say return res.map. Then we're going to open up the brackets, say $0 dot map. Open up the brackets again. We're going to say, well, let's do it like this, make it a little bit more legible for y'all. So, boom, boom, excuse me, boom. Oh, remember, this $0 represents each array inside of the array, right? So each array, this is going to represent each array. Boom. So we're going to say dot map. Then we're going to come open up brackets. We're going to say in, come, now we come right here. Hold on, let me clean this up. Hold on now, y'all. Oh yeah, let's clean that up. Sorry, y'all. Boom. So now we can come right here, and we can say, open up the parentheses. We can say 0 dot dot less than n. So 0 up to n. 0 up to n dot map Then we're going to open up the brackets and we're going to say J and open up the parentheses. I equals J. Come outside or still inside the parentheses, we'll say question mark. This is Boolean, so if it's true, then we put this question mark. So if it's true, we're gonna put Q, so a string of Q. So open up the quotation marks, put a Q inside, and if it's false, we're gonna say colon. Open up the quotation marks for the string and put the period for the blank space. Then we're gonna come outside of this this bracket, and we're going to say dot joined to join them all together, and this is going to convert the column indices to the board representation. Boom. So now let's go ahead and run this. Let's go ahead and run it. Make sure it runs like it's supposed to before we submit it. Ooh, we got an error. What does it say? What does it say? Expected separator. Okay. So let me see. Sorry, y'all. Oh, equal white space, y'all. Equal white space. All right, let's run it again. Hopefully it runs correctly this time. And look at that, y'all. It's accepted. So let's go ahead and submit it. Make sure it stays accepted after we submit it, because we all know how LeetCode can get. Ooh, look at that. 5 milliseconds beats 48.25% of users with Swift, y'all. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to get to a point where we can solve the problem that's presented to us. And I feel like this is a good solution for that, because it's important to understand the solution so that you can use that knowledge further on in your LeetCode journey. If you don't understand the solution, then you're not going to be able to use what you learned in future solutions, y'all. So that's why it's important to understand the solution and understand what the code is doing. So with that being said, get one more look at the code, y'all. This is the top half right here. Boom. This is the bottom half right here. Boom. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.